Okay, I have number 3 started. We have a set of right angles. We have a pair of equal sides. Okay, let's see. So the right angles, I'm not sure right now where I'm going with that, so I'm going to wait on that given. But I want to look at the diagram. I do see something on the diagram I can mark. I do have a reflexive set of angles, so that's my next step here. So I'm going to put double marks on KM because those are reflexive. I have a reflexive set of sides. I think I may have said angles just a second ago. So let's focus on the sides. So segment KM is congruent to segment KM, and that is the reflexive property of congruence. Oops, let me make that a little bit better. Okay, now let's look at the picture. Because every time you write something, I want you to pause and see, do you have what you need? So I actually do have one of my theorems. I have hypotenuse leg. I have HL. But the one thing about HL that's a little bit tricky is I need, really, even though HL has two parts, hypotenuse and leg, there's really a third kind of hidden part, and that's the fact that I must have a right triangle. Now, when I look at this, I know I have a right triangle because I know what a right triangle is. I know that a right triangle has one right angle. But in a proof, it's very formal, and I need to establish that that's happening. So, because I'm starting in my given that I have a right angle, I need to say something that talks about what I know the definition of a right triangle to be. So here's what we need to write next before we finish with HL. So I know that this is a right triangle because I know the definition. So I just need to say something like this. I need to say that triangle JKM and triangle LKM are right triangles. So I'm writing just a short little sentence here, short little phrase. And my reasoning is just definition of right triangle. And if you want to use the draw a little triangle in place of the word triangle, you can. So I now have my hypotenuse marked, I have the corresponding leg marked, and I have established that it's a right triangle. Now I'm ready to be done. So I'm ready to have step 4 be naming the two triangles in the prove line. So triangle JKM is congruent to triangle LKM, and that is HL. Okay, so line 3 there is a little bit tricky. I'm not sure we've seen a proof like that yet, but that is something that you need to account for if you're using HL. Now, if my given would have said that these are right triangles, then I don't have to worry about including it in my proof because it's in the given. Okay, let's get to number 4. So I encourage you to stop the video, get things as far as you can, and then come back. Okay, BD is perpendicular to AC, so I probably would have put that right angle on there if it wasn't already there. D is the midpoint of AC. Okay, let's think about what we have. I'm going to use the midpoint given first. So if D is the midpoint of AC, well, what does that mean? Well, that means D is cutting AC in half. So I know that these two segments are congruent. So that's what I'm going to put next. Okay, I don't have to do this next, but there's going to be we can have some differences in order. So somewhere in your proof, you need to say that segment AD is congruent to segment CD by definition of midpoint. Okay. All right. I also have a reflexive property here. So I'm going to go ahead and mark that. So somewhere in your proof, this could have been line 2 for you, we need to state that BD is congruent to BD, reflexive property of congruence. Okay, what does my picture show me? All right, I have a right angle, but I don't have HL. I don't have the hypotenuse being congruent, and I'm not sure I can get that right now through another, theorem. But I do see that the two right angles, this angle right here is also 90. And so I could use SAS right here. I've got the 90 is the angle and then the two sides. So I can do that, but my only problem right now is in my proof, I have a side listed and a side listed, but nowhere do I actually come right out and say that those two angle Ds are congruent. So I need to get that in my proof, okay? I need to show that. Okay, now, a couple things here. I know that that's a right angle on the diagram, but nowhere in my proof am I saying that. So let's establish, I'm going to have to do two things here. I'm going to have to say, hey, I know that those angle Ds are both right angles. And then I also know that if I have two right angles, the right angles are congruent. Okay, so let's do step 4. And I'm going to write a little phrase here. So I'm going to name both angles. So I'm going to say that angle BDA, I'm naming the right angle more on the left. So angle BDA and angle BDC are right angles. Let me make that a little bit more legible. And I know that because I know that the perpendicular lines by definition make right angles. So this is a definition of perpendicular lines. Now, I still haven't said that they're equal. So we had a theorem that said that all right angles are congruent. It was called the right angle congruence theorem. So I'm going to say step 5, I'm going to now say that these two angles are congruent. So I'm going to say BDA, angle BDA is congruent to angle BDC. And our textbook called it right angle congruence theorem. You could just say all right angles are congruent. That's really what the theorem said. Right? I'm going to use the angle symbol. Right angles congruence theorem. If you really just said right angles are congruent, that's fine. Okay, now what I have here, I want to kind of point something out. I have a side listed in my proof. I have another side, and I have an angle listed here. Okay, so I must have those statements. Now, they don't have to be in the order of SAS, but I see on my picture that I have side angle side. So let's wrap our proof up with number 6. Now copy down the two triangles. Triangle ABD is congruent to triangle CBD, and that is going to be SAS. Okay, so when you're going to, just a couple of things I want to point out. Let's switch here. So I want to compare number 3 and number 4 for a minute. Okay, number 3. If I'm going to use HL, I don't need to show that those two right angles are equal to each other because HL doesn't include saying that the right angles are equal. I just need to establish it's a right triangle. So in number 3, I didn't have to show that J and L were right angles because I wasn't going down the SAS route. Or I should say, I wasn't going down a route that I needed the angles in. But number 4, though, when I saw I needed SAS and I needed to show that the two 90s were the same, then I needed to establish, I'm going to put kind of brackets around these two lines. If I need to show that right angles are congruent, I'm going to have these two together in a proof because I need to establish how do I know that those are right angles, and then I need to establish that they're equal, okay? So you need to kind of, as you work through this now, you need to kind of think about when do I need which piece? And so those are some things I'm really going to encourage you to start focusing on. Like I said, I hope that the proofs are feeling easier. I hope you're getting a little more comfortable with them. And we're just going to continue to try to work as many as we can.